Alright, so now we're going to look at vertex form of a quadratic function. We've talked a little bit about transformations before, so this is really going to be another way that we call vertex form is transformational form, because it shows us the transformation of the vertex. So we've seen when we use the word vertex, that is the low point or the high point of a parabola. We've heard that word before too if you're taking a geometry class. We have the vertex of an angle or vertex of a polygon or vertices of a polygon. It's the corners, right, or the turns. Well, we don't have a sharp turn with a parabola, but it's the turning point. That's the vertex. It's labeled HK because of our vertex form. So this is our vertex form of a parabola, where here is H and here is K. So we're going to see in a little bit, these are our transformations as well. Now, first, I want you to just kind of do a little practicing on your own. So here are 6 different equations. They all have a lot in common, but they're not, none of them are the same. I want you to match these equations with these graphs. In doing that, I also want you to identify the vertex of each and give a sentence, or it doesn't even have to be a complete sentence, just some reasoning why you chose that equation with that graph, what your thought process was. And by all means, use your calculator to help you if you need to. The graphing feature on the calculator can be very helpful. All right, so pause the video, match those, unpause when you're ready to discuss. All right, so hopefully you got that equation A goes with graph D, equation B goes with graph C, equation C goes with graph A, equation D goes with graph F, equation E goes with graph B, and equation F goes with graph E. Now let's talk real quick about how did we come up with that, really. So if I look at these graphs, right, only 2 of them, B and D, have the same vertex. So for the rest of them, really, I was able to I identify the vertex for all of them, and I was able to use the vertex to identify which graph goes with which equation. Now, we can also look at a few other things as well, and so I've identified that, and specifically going back to equation A and equation E, because those had the same vertex, what I looked at was this negative out in front, that's going to flip the graph. And when I say flip, so when I look at graph D, notice that the parabola is opening down, right? That's what I mean by flip. Versus equation E, which also had the same vertex, didn't have a negative in front, it actually had a 2. So what the 2 is going to do, and we'll talk a little bit more about this later, but we've seen this previously as well, that's going to stretch the graph, or it's going to be what we call a vertical stretch. So it makes it look a little bit skinnier. Now with these graphs, it's hard to tell what's going on necessarily in terms of stretches and shrinks, but that's what's happening there. And then again, the rest of them I just identified from the vertex. I did still note, so for instance, this graph had a flip as well. This graph, the 0.5, is actually going to shrink it vertically, so I said it was shrunk. And so we can see that here a little bit where, and again, it's hard to tell because the shape is a parabola, but it's kind of smashed down vertically, which then makes it actually appear to be a little wider. And then graph F also had the negative in front. I'm sorry, equation F, which was graph E, so that one also had a flip. All right, so this next slide here is talking about horizontal translations or shifts and vertical translations or shifts. Now, I will say before we get into this exactly that I'm really only showing you this because if you look in a book or look online, this is the kind of notation that you might see when we talk about horizontal transformations or vertical transformations. Personally, I think, especially with the horizontal, some of this notation makes it look more complicated than it really is. If we understood how to find the vertex here, then we already know how to do these transformations. But the thing you want to understand is, okay, it's going to shift horizontally, so left or right, if there's something added or subtracted in the parentheses that are then being squared, right? And we're specifically talking about quadratic functions right now. If something is added or subtracted outside of the squared term, that's going to be a vertical translation. If that thing outside is positive, then it's going to shift up. If it's negative, then it shifts down. Another way we can think of that is we're going to add or subtract whatever that k value is to all of the y values in the equation. The opposite is true with horizontal translations. And we can see this here, for instance, when I have x minus 2 squared, that shifted the graph 2 to the right. So it's a minus 2 in the parentheses, which went 2 to the right, as opposed to here, where it's a plus 2 in the parentheses, so that went 2 down. I'm sorry, 2 to the left. I misspoke. This is a plus 2 in the parentheses, so it went 2 to the left, as opposed to the plus 2 outside of the parentheses, that went 2 up. So again, if it's inside, and that's what this is telling us with h is greater than 0 versus h is less than 0. If it's inside the parentheses, we do the opposite of what we see here, in terms of if it's a minus, that's going to shift it to the right, whatever this number is, and if it's a plus, that'll shift it to the left, whatever that number is. We add or subtract those values to the x values. A couple other transformations, and you heard me mention this as well in the first part. So reflections, right? If I multiply the quadratic by a negative, or another way to say that, if the negative is outside of the squared quantity, that's going to reflect over the x-axis, or what I was saying before is flip the graph. So that's when we have a negative here. Another way to think about that it is literally multiplying all of the y values by a negative 1. Now I would point out, again, if you look in a book or online, we can have reflections over the y-axis as well, but when it comes to quadratics, that doesn't really do anything. So we're not going to talk about those here. Vertical stretches and shrinks. So this is another thing, again, I talked about at the beginning with, so I'll go back to those. This 0.5 would be a shrink, and this 2 was a stretch. So that's what we mean by vertical stretches and shrinks. And also, just to clarify, the negatives, those were the reflections in the x-axis that I just talked about. So a vertical stretch or a shrink is a number, again, multiplied outside of the squared quantity. We can have numbers inside the squared quantity that would be a horizontal stretch or a shrink, but again, when we're talking about quadratics, that's a kind of a strange way to think about it. So we're not going to really focus on that. We're just going to focus on the vertical stretches and the shrinks. And basically, if the number is larger than 1, it's going to stretch the graph, which will make it look skinnier. If the number is between 0 and 1, then it will shrink the graph, which will make it look wider. And we know if it's less than 0, then it's a flip, not a stretch or shrink. And again, what you're doing, though, is you're literally multiplying the y values by whatever that a value is. All right, so that was a lot of formal notation and me talking, which is great. I love to hear my voice, but this is you that gets to hear my voice. So let's do some examples. F of x equals x squared, right? That's our parent function of our quadratic. And we want to write a new function for g of x that's left 7, has a vertical stretch by 4, and is down 6 units. So g of x equals, if I'm going left 7, then I know there's going to be x plus 7 squared. That's my left 7. If we have a vertical stretch by 4, then there's going to be a 4 in front of this, because I'm multiplying the y values by 4. And then if I'm going down 6, there will be a minus 6 outside of that. So then the question is, where's the vertex? -7, -6. Any questions? All right, moving on. Let's try this one. So here again, f of x equals x squared, but we want to reflect over the x-axis, up 9, and then right 2. What is that going to look like? Good question. So we have g of x and then we are going to go right 2, so I'm going to do x minus 2 squared, and then we are going to go up 9, so I'm going to do plus 9, but we have a reflection over the x-axis, so that means we're going to throw a negative in front. That looks great. All right, vertex. What's the vertex? Good question again. You guys are spot on with your questions today. I appreciate that. Vertex is 2, 9. Perfect. All right, I want you to try this one on your own. This is going to be a little bit more difficult. It's not as straightforward because the parent function, or I should say the base function that we're working off of, this one be called parent function in this case, is x plus 3 squared minus 1. So we want to take that function and move it left 2 and up 8. So write the new equation and write the new vertex. Pause the video, unpause when you're ready to discuss. Alright, so hopefully you got x plus 5 quantity squared plus 7 and a vertex of negative 5, 7. Now, if you didn't, or if you're confused, what would my thought process be on this? Great question, glad you asked. So first, if I want to move this function left 2 and up 8, I first want to think about where is that function. So I identified the vertex of f of x, and the vertex of f of x is negative 3, negative 1. So now I want to think about, okay, if I'm moving 2 to the left of negative 3, that's going to put me at negative 5. If I'm moving 8 up from negative 1, that's going to put me at positive 7. So then I just need to write my equation to have that vertex. So what I'm trying to say basically is I identified the vertex of f of x, which then allowed me to identify the vertex of g of x, which then allowed me to write the equation. So I didn't go necessarily in the order in which the problem is kind of phrasing the question, but I went in the order that was most useful for me. Okay, the next couple examples are hopefully going to be a little bit straightforward. We're just given a function. I want you to identify the vertex, describe the transformations, and then just graph the function. Pause the video, do that, unpause when you're ready to check. And if you're stuck on doing all of that, just try to do some of it. Just identify the vertex maybe, or the transformations, or use your calculator and help you graph. All right, pause the video. Okay, hopefully your graph looks something like this. I have a few points plotted. My vertex, though, that's important. That is the point 3, 1, because the graph went right 3, up 1. You can use the table feature on your calculator to come up with a couple of other points. You might also start to notice patterns on how the points of a quadratic work once you know the vertex. You might also start to notice symmetry. This is something we're going to be talking about more in a later video, but that can help us graph as well. All right, same thing, different problem. Try this, identify the vertex, transformations, and graph the function. Pause the video, unpause when you're ready to discuss. All right, so here our graph should look something like this. Our vertex is at negative 1, negative 5. Our transformations were left 1. We had a vertical stretch. Sorry, I kind of ran that all together as one word, it seems. Sorry, I just realized from that last problem something didn't look right with my sloppy handwriting, and I misspelled stretch twice. Anyway, we went left 1, vertical stretch, or multiplied the y values by 2, and then we went down 5. So our graph looks something like this. All right, another graphing problem. So same as before, identify the vertex, transformations, and do a sketch of the graph. Pause the video, unpause when you're ready to discuss. Okay, so here our graph is flipped, so it should look something like this. Our vertex is at 4, 3, so I've got the point 4, 3. Because we went right 4, reflect over the x-axis or flip, and then up 3. Alright, so to conclude this video, we really want to go back to our central question from the beginning of the video, and that is how do the constants a, h, and k affect the graph? And those are going to be our transformations, but h and k are also going to be our vertex as well, which is part of the transformation. So the vertex is the point hk, h is going to be our horizontal, so left and right translation, k is our vertical, so up or down, and a is going to be either a vertical stretch or a shrink, and or a reflection if it's negative.